Welcome back, students. Today is the session 18 of JEE Physics and the chapter is Current Electricity. And I have taken this question from the JEE mains examination. This question was asked in the year 2014. In 2014. Now, in this question, it is written that there is a building in which there are 15 bulbs of 40 watt, 5 bulbs of 100 watt, 5 fans of 80 watt rating, and 1 heater of 1 kilowatt rating. The voltage of the main supply is 220 volt, and so we have to find the minimum capacity of the fuse. Now, a fuse is installed in an electrical circuit in order to protect these electrical appliances of any infrastructure in case of any electrical fault such as a short circuit. So, however, the minimum capacity of the fuse is equal to or slightly more than the maximum current which will be withdrawn from through the electrical circuit in case all the electrical appliances are running at the same time. So in this case, we have to first of all find the total power consumption when all these electrical appliances are running at the same time, and thereafter we have to find the maximum current which will flow through an electrical circuit in case all these electrical appliances are running at the same time. So here the power consumption P is equal to there are 15 bulbs of 40 watt. So 15 bulb of 40 watt, which is equal to 15 into 40 plus 5 bulbs of 100 watt. Then there are 5 fans of 80 watt plus 5 fans of 80 watt rating. This is the 80 watt is the rating of one fan. And here this 40 watt, 80 watt and 100 watt, these are the rating of one bulb. So 15 watt का जो total power consumption है, that the total power consumption of 15 watt, so 15 bulb will be equal to 15 into 40. The power rating of one bulb is 100 watt, so the total power consumption of 5 bulbs will be equal to 5 into 100 watt. The power rating of one fan is 80 watts, so the total power consumption for 5 fans will be equal to 5 into 80, and the power consumption of this heater is 1 kilowatt, so there is only one heater, so 1 into 1000 watt. I am converting this kilowatt into watt. So this is also watt. This is watt plus this is watt. This is also watt, and this is also watt. So the total power consumption is equal to, this one is equal to 600 watt plus 500 watt plus 400 watt plus 1000 watt. So if we add it up, it will be 6 plus 4, 1000, 1000, 2000, 2500. So the total power consumption in case all the appliances are running at the same time is equal to 2500 watt. So if all the appliances are running at the same time, then the current, that is, now we know that P is equal to VI, so the current I will be equal to P upon this V. Now the total power consumption is 2500 watt. Voltage supply is equal to 220 volts. यहाँ दिया हुआ है. Okay. Now this is a 220 volt is normally it is a single phase supply. Okay. Whenever you find the supply voltage as, let's say, 415 or 420 or 440, then it is a 3-phase supply. So this is a single phase supply. So in the case of a single phase supply, the power rating is given by P is equal to VI. Okay. So now here the value of I is equal to, so that is equal to 111.40 11.36 ampere. So the maximum current which will flow through the electrical circuit when all these electrical appliances are running at the same time, it will be equal to 11.36 ampere. So the capacity of the fuse should be equal to or more than this value, because अगर इससे कम होगा, if the value of this fuse is less than 11.36 ampere, then what will happen? Then in case if all the appliances are running together, then in that, for example, if you have installed a fuse of, let's say, 11 ampere, so what will happen in case if all the appliances are running at the same time, then what will happen? The fuse will blow off, and then there will be no power supply. So in that case, what we do is, if the maximum current requirement is, in this case, is 11.36 ampere, so we will install a fuse which is slightly more than this value. So here we have got four options: 8, 10. Now we cannot use 8, because if we will use 8, then what will happen? The fuse will get blown off when all the appliances are moving, are running at the same time. Similarly, we cannot use this fuse also, because again, if all the appliances are running at the same time, then the fuse will get blown off. Third answer, that is 12 ampere. 12 ampere should be the minimum capacity of the fuse out of these four alternatives, because the maximum current which will flow through the electrical circuit in case all the appliances are running together, then it will be 11.36. So if I install a fuse of 12 ampere, then all my appliances will continue to run without any power failure. So the correct option is C, that is 12 ampere, because the maximum current which will flow through the electrical circuit when all the appliances are running together or at the same time is 11.36 ampere. So this question was asked in the JEE main examination in 2014. So I think that this is a very easy question, and probably the only thing which you have to remember here is that a fuse is installed in any infrastructure taking into care the maximum current requirement of that particular infrastructure. If the maximum current requirement was, in this case, was 11.36, so we have installed the fuse of 12 ampere. Okay. So thank you very much for joining this session, and in the next session I will be continuing with the same chapter, that is current electricity. So in the next session I will be taking up the few questions from the this JEE Advance, which was asked very recently. So this was a question which was asked in the JEE mains examination, but in the next session I will be taking a question which was asked in the JEE Advance. So thank you very much, and have a nice day. Bye.